Super Typhoon Dolphin is crossing the Pacific right now with 168 mmPH sustained winds, 195 mmPH gusts, and 42-foot waves, and every forecast model on the planet is pointing it toward one place: Kumamoto, Japan. The same city where rescue crews are still pulling bodies from a magnitude 7.1 earthquake that struck 2 days ago. 23 people are confirmed dead. 300,000 are living in emergency shelters. 48,300 homes have no power. The main expressway is cracked open. And the strongest storm to form in the western Pacific this year is now barreling directly toward all of it. Dolphin gained 150 kilometers per hour of wind speed in a single day, the fastest intensification since 2022. And forecasters say it could reach 190 mmPH by tomorrow. This is not a coincidence of timing. This is a monster super typhoon locked onto the exact coordinates of an active earthquake disaster zone, and Japan has never faced this combination in the modern record. Today we are going to break down exactly what happened in Kumamoto, how powerful Super Typhoon Dolphin has become, where it is heading, and what happens when a super typhoon strikes a region that is already broken. No dramatizing, no guessing, just the confirmed data, the forecast models, the science behind what makes this so dangerous, and the real human stakes on the ground right now. If you have been through a typhoon, an earthquake, or both, we want to hear from you. Drop a comment below and tell us where you were and what it was like. Your experience matters to this community. And if this is the kind of coverage you count on, calm, factual, and ahead of the story, subscribe to Earth Dispatch right now so you do not miss a single update as this situation develops over the coming days. The earthquake struck at 4:27 p.m., local time on July 28th. Rush hour. Trains full, highways packed, schools letting out. The ground moved at seismic intensity 7, the absolute highest reading on Japan's earthquake scale. At that level, reinforced concrete buildings can be destroyed and the ground itself cracks open. That is not a description. That is what the scale is designed to measure. The Japan Meteorological Agency measured the quake at magnitude 7.1. The United States Geological Survey put the moment magnitude at 6.8. Both numbers describe the same event. Both numbers describe an earthquake that released enough energy to be felt more than 400 miles away, with 291 separate reports of shaking coming in from Busan, South Korea. The maximum intensity readings came from Uki City and Hikawa Town. Those two communities sit almost directly above where the fault ruptured. The ground under them did not just shake, it jumped. Buildings there did not sway, they snapped. As of July 30th, the confirmed death toll is 23 people. That number is still climbing. Rescue teams are working 2 major collapse sites and pulling bodies from smaller ones. 63 more are injured, 5 of them seriously. Emergency crews are running on almost no sleep, and the ground is still moving under their feet. The Japan Meteorological Agency recorded 190 aftershocks in the first 24 hours alone. An aftershock is a smaller earthquake that follows a large one, caused by surrounding rock adjusting to the sudden change. 190 of them in one day means the ground beneath Kumamoto has not stopped moving since Tuesday afternoon. Each one weakens whatever the main quake did not already destroy. At the Aeon Mall, Kashima, the second floor gave way. Shoppers and staff were still inside. Roughly 1 hour after the initial collapse, an explosion tore through the structure, likely from a ruptured gas line. 5 people were killed inside the mall. 3 workers are still missing under the debris. Rescue crews there are moving slabs of concrete by hand because the heavy equipment cannot get close enough without risking further collapse. At the Nippon Paper Industries factory in Yatsushiro, a large industrial chimney came down across the plant floor. 5 workers died. Others may still be trapped inside. The factory site is unstable, and search teams are cycling in and out in short shifts because of the danger. 300,000 residents are under evacuation orders. They are sheltering in schools, community centers, and municipal gyms. These buildings were designed for earthquake response. They were not built to withstand a super typhoon. Many of them have single-pane windows and lightweight roof structures. 48,300 households lost power in the initial hours. Hospitals across the affected zone went dark and are running on backup generators. Staff at 3 regional hospitals are relocating patients on ventilators because the diesel supply feeding those generators has a fixed number of hours before it runs out. Sections of the Kyushu Expressway, the main artery running through the region, are closed. An elevated portion cracked open along its span, and inspectors have not yet cleared it for even emergency vehicles. Detour routes are adding 2 to 3 hours to trips that normally take 40 minutes. Kumamoto Castle was damaged again. The castle was still under active restoration from the 2016 earthquake, a project that was scheduled to run into the next decade. That work is now on hold indefinitely. And through all of this, the temperature outside is 33 degrees Celsius, which is roughly 91 degrees Fahrenheit. The Ministry of Environment has issued a heat stroke alert specifically for evacuees. People sleeping on gymnasium floors, standing in line for water, and searching for missing relatives are doing so in dangerous heat with limited shade and limited air conditioning. This is not the first time Kumamoto has experienced this. and the history of this fault line is exactly why scientists are watching so closely right now. 10 years ago, this same region was hit by a sequence that changed how Japan thinks about earthquakes. The 2016 Kumamoto earthquake killed 277 people, and there is a reason scientists immediately referenced it when this new quake struck. The 2016 sequence started with a magnitude 6.5 foreshock on the evening of April 14th. Residents evacuated, emergency crews arrived. The country began the process of responding to what it thought was the main event. Then, just 28 hours later, the actual main shock hit at magnitude 7.3. It was the first time in the history of the Japan Meteorological Agency that 2 intensity 7 quakes occurred in a single sequence. 277 people died, including indirect deaths from the disruption. 2,109 more were injured. The fault responsible was the Hinagu Fault. The Hinagu Fault is an 81-kilometer active fault running directly under Kumamoto Prefecture. It ruptured along most of its length in 2016. In 2026, according to analysis published by Earthquake Insights, the new rupture extends southward from where the 2016 rupture ended, with a potential overlap zone at the boundary. In plain language, the fault kept going. It picked up right where it left off 10 years ago. The motion in both cases is what geologists call strike-slip faulting. Strike-slip faulting is when 2 slabs of earth slide sideways past each other instead of one pushing over or under the other. That sideways motion is what tore through Kumamoto in 2016, and it is what tore through Kumamoto again this week. The energy travels differently than a vertical thrust quake. It shakes buildings side to side, which is particularly hard on older wooden homes and unreinforced concrete. The Aeon Mall that just collapsed had only reopened last month. The original structure was destroyed in 2016. The rebuild took nearly a decade. It opened its doors for full operations in June. 6 weeks later, its second floor was on the ground. That fact is not incidental. It is the story. This is a region that spent 10 years rebuilding from one earthquake, only to be hit by another on the same fault system, in the same week that a super typhoon began forming out over the Pacific. The Japan Meteorological Agency has issued a specific warning. In the words of the agency, past cases in this region show that comparable earthquakes can follow within 1 week of an initial event. That is the 2016 pattern. A large first quake, then a larger second quake, 28 hours later. Right now, Kumamoto is inside that window, and the ground has already produced 190 aftershocks to prove it is still active. Scientists watching the fault do not know whether another intensity 7 quake is coming. They do know the conditions that produced one in 2016 are present again. They do know the fault has not fully settled. They do know that the same physical process that ruptured a 40-kilometer section this week could extend further, but it is not another earthquake that has forecasters most alarmed right now. While the ground beneath Kumamoto is still shifting, something far larger is building in the open Pacific, and it is heading this way. On July 27th, Typhoon Dolphin was an ordinary tropical storm. By July 29th, it was one of the most powerful cyclones on the planet. What happened in between is the definition of rapid intensification. Rapid intensification is when a storm's wind speed jumps by at least 35 meters in a single day. Dolphin did not just cross that line, it tripled it. The storm's sustained winds climbed by 150 kilometers per hour over a 24-hour period. That is a 93-hour increase in one day. It is the fastest intensification event in the Western Pacific since Typhoon Noru in 2022. Dolphin is now a super typhoon. A super typhoon is a typhoon with sustained winds above 150 hour up. Think of it as the Pacific Ocean's version of a Category 5 hurricane. Dolphin's current sustained winds are 270 kilometers per hour, or 168 miles per hour. That is faster than the vast majority of tornadoes most Americans have ever experienced, only sustained over hundreds of miles of ocean instead of a single track through a town. Peak sustained winds so far have reached 285 kilometers per hour, which is 177 mph. AccuWeather has clocked wind gusts inside the eye wall at up to 195 km. The ocean around the storm is responding accordingly. Significant wave heights are running at 42 feet right now. That is the height of a 4-story building, moving outward from the storm center in every direction. Ships in the region have been rerouted hundreds of miles to avoid it. Dolphin is currently 389 kilometers south of Wake Island. That distance is closing. The Joint Typhoon Warning Center now forecasts peak sustained winds of 305 kilometers per hour, or 190 stormed, by July 31st. That would place Dolphin in the company of the strongest storms ever recorded in the month of July. The Korea Meteorological Administration is forecasting the storm's minimum central pressure to drop to 915 hectopascals by August 3rd. Central pressure is the air pressure at the very center of a storm, measured in hectopascals. The lower the number, the more violent the storm. 9-15 puts Dolphin among the most intense readings any tropical cyclone reaches anywhere on Earth. For context, Typhoon Nepertak in 2016 was the strongest July storm of the 21st century. Dolphin is on track to rival it. If the forecast peak holds, Dolphin will approach the strength of Typhoon Wanda in 1956, which remains the strongest July typhoon in the entire recorded history of the basin. Dolphin is the third super typhoon of the 2026 Pacific season. The season is being driven by El Nino. El Nino is a natural warming of Pacific Ocean waters near the equator. The current event is on track to become the strongest ever measured. Warmer surface water is the fuel that tropical cyclones run on, and this ocean is more heavily fueled than it has been in decades. Storms grow faster. They reach higher peak intensities, and they hold onto that intensity for longer. There's one more mechanic worth understanding. Dolphin recently completed what meteorologists call an eye-wall replacement cycle. An eye-wall replacement cycle is when the inner ring of a typhoon's strongest winds breaks apart and a new wider ring forms around it. The storm briefly weakens, then often comes back even stronger and covering a larger area. Dolphin did exactly that. It weakened slightly, then resumed explosive intensification with a wider wind field. The comparison forecasters are already making is to Typhoon Sinlaku from April of this year. Sinlaku reached Category 5 with 285 km/h winds and a central pressure of 905 hectopascals. It killed 17 people in the Mariana Islands and caused $458 million in damage. Dolphin is currently on a trajectory to match or exceed those numbers, and it is aimed at a far more populated region. A storm this powerful over open ocean is a scientific event. A storm this powerful heading toward a region where 300,000 people are sheltering in earthquake-damaged buildings is a humanitarian crisis. And right now, that is exactly what the forecast models are showing. Multiple forecast models, including the American GFS and the European ECMWF, are now pointing Dolphin toward the same stretch of southwestern Japan that is still counting its dead from Tuesday's earthquake. The projected landfall, or closest approach window, sits between August 5 and August 7. That is roughly 1 week from today. The GFS and Euro ensemble models place Okinawa and the southwest island of Kyushu inside the forecast cone. Kyushu is where Kumamoto sits. The Korea Meteorological Administration is monitoring a contraction of the North Pacific High, the atmospheric feature steering the storm. If that high contracts as expected, it could open a pathway that pushes Dolphin toward the Korean peninsula as well. The exact landfall location is still uncertain because the storm is 7 to 8 days out, and steering patterns at that range can shift. What is not uncertain is what sits in the current forecast cone. Kadena Air Base is 2,680 miles from Dolphin's current position, and the gap is shrinking daily. Camp Foster and Marine Corps Air Station Futenma are on the same island. All three are major U.S. military installations. All three are now inside the outer edges of the forecast cone. U.S. military bases in the Pacific use an alert system called TCOR. TCOR is the alert system used to prepare for typhoons. At the highest levels, all aircraft evacuate the base, ground personnel lock down facilities, and everyone shelters in place. Kadena is currently at seasonal readiness. If Dolphin's track holds, that status will escalate rapidly over the coming days. 1. 4 million people live on Okinawa. They are experienced with typhoons. The buildings there are built for them. But even Okinawa has never taken a direct hit from a storm forecast to reach 190 mm. Concrete homes can survive a Category 4. A 190 mm super typhoon is a different structural test entirely. And then there is Kumamoto. 300,000 evacuees are currently in temporary shelters that were never designed for typhoon winds. The Kyushu expressway is already fractured. Bridges are cracked. Evacuation routes that officials would normally use to move people out of a typhoon path are compromised. Hospitals are already running on backup power, and moving critical patients out of the region is a multi-day operation on intact roads. On broken roads, in aftershocks, in heat, it becomes something else entirely. There is also the seismic risk running on a parallel clock. The Japan Meteorological Agency warned that comparable earthquakes can follow within 1 week of an initial event. That window extends into the same days the typhoon is projected to arrive. Aftershocks could occur just before, or even during, the storm's approach. Rescue crews, shelter operators, and medical staff would be responding to a moving ground while a super typhoon closes in. Officials in Kumamoto Prefecture, in Okinawa, and at the national level are now running parallel operations. Search and rescue at the earthquake sites, shelter management for 300,000 people, storm preparation across a 700-mile arc of coastline, coordination with U.S. military commanders on Okinawa. Every one of those operations is competing for the same helicopters, the same trucks, the same personnel, and the same hours in the day. What makes this situation different is not the earthquake by itself, and not the typhoon by itself. It is the fact that both are happening to the same people in the same place within the same week, and the window to prepare is already closing. There is a scenario that emergency planners in Japan are already thinking about, even if nobody is saying it publicly yet. When typhoon rainfall lands on hillsides that have been loosened by an earthquake, the ground does not behave the way it normally does. Water penetrates through cracks that did not exist a week ago. Soil that would have held on a normal slope slides. In 2016, the Kumamoto earthquake triggered massive landslides that buried entire villages and swept away sections of road. Those landslides happened on ground that was dry. The same hillsides are now cracked again from Tuesday's quake. If Dolphin arrives with the rainfall totals a Category 5 typhoon produces, the slopes above Kumamoto's valleys and the mountain passes, carrying its highways, face a landslide risk that has no clean historical comparison. The buildings tell a similar story. Structures weakened by 190 aftershocks, and one main shock will then be asked to hold together against sustained winds above 168 mph. Roofs already partially peeled, walls already cracked, windows already broken and covered in plywood. Wind at that speed finds every seam. The power restoration timeline for the 48,300 households currently in the dark is measured in days under normal conditions. If Dolphin makes landfall, the timeline resets to 0. New poles fall, new lines break. The utility crews now working around the clock are the same crews that would need to secure their own equipment before the storm arrives. The evacuees themselves face a decision no emergency system is designed for. The schools and gyms they moved into on Tuesday were the safest option after the earthquake. Those same buildings become the wrong option if a super typhoon lands on top of them. 300,000 people may need to evacuate their evacuation shelters and move again into structures rated for typhoon force winds in a region where those structures are already at capacity. Japan has one of the most sophisticated disaster response systems on Earth. It has been refined by decades of earthquakes, typhoons, tsunamis, and volcanic events. But in the modern record, Japan has never faced a super typhoon striking an active earthquake disaster zone in the same week. There is no playbook for this specific combination, because it has not happened before at this scale. Consider the two images side by side. On one side, a rescue worker in Kumamoto pulling a survivor from a collapsed shopping mall in 91-degree heat, moving concrete slabs by hand while aftershocks continue underneath. On the other side, satellite imagery of Super Typhoon Dolphin, its eye wider than the city of Kumamoto itself, closing the distance across the Pacific at 13 miles per hour. One image is the present, the other is the future. And both are happening at the same time to the same people. One country is still responding to the disaster that just hit, while another disaster is already on the way. The most dangerous moment in any disaster is not the event itself. It is the window between the first catastrophe and the second one. That is when people are exposed, when infrastructure is broken, when the systems that would normally protect them are already stretched, and when the next blow has not landed yet. Japan is in that window right now. Here is the question we want to leave you with. If a second emergency hit your area while your local system was still dealing with the first one, would your community be ready? Does your city, your county, your region have an actual plan for back-to-back disasters? Or does it have one plan that assumes only one thing goes wrong at a time? Have you ever lived through that kind of overlap? Tell us in the comments. Real experiences from real places help everyone reading think more clearly about their own. This story is going to develop every single day for the next week. New forecast tracks, new damage numbers, new decisions from Tokyo, from Okinawa, from Washington. Earth Dispatch will be covering every update with the same calm, fact-based approach you just watched. Subscribe so those updates reach you the moment they go live. And if you know someone in Japan, in Okinawa, or anywhere in the Pacific Corridor, share this video with them now. They may need the timeline more than you do.